Recording. Okay, gang. So let me get my screen share going for anybody that's going to watch later. And we'll go over today's lesson. So did everybody check my speaker? All right, whatever. My speakers are fine. What are you talking about? Look at this thing. Go away. So did everybody seem to be able to figure out how to make your test work? I think I had one person who had trouble with the test because it wasn't done, but everybody else got it done. So that's excellent. All right. And then I don't have a message to it. Oh yeah, they're running late. Okay. Dylan and Annabella are 15 minutes late. Oh, Annabella's at home. And let me tell her real quick, she can log in if she wants to, so that she knows. So everybody's new to this. Okay, let's see. Everything is crazy this morning. All right, I want to hand back the Ricos that I have, although I don't know who they belong to. So you're gonna have to claim your Rico. So who did Rico in tie-dye and rainbow?
That was me.
That was you. I like it. And who did Rico in? I don't know, Technicolor. Ah, there you go. And then, so who is this Rico? Is this you? There you go. All right, cool. Those are awesome. We just need to remember to stick our names on them because that makes it much easier to tell who's is who. So today we're talking about, we're working in our ecology unit. We're starting our unit on ecology. And after we finish ecology, we're going to move on to cells, and that'll be a lot of fun. So the way we're doing tests this year is like we did tests last year for chemistry, where it's one per unit. You good, Lil? You got you're probably gonna want your papers out and stuff, so you're all focused in. So energy flow in systems. These leaves kind of reminded me of, I thought they're really pretty, the color, but we have canna lilies down there and they have very similar leaves. And we noticed this year we got these bugs in them, these little worms, and they would get inside the leaf and they would roll the leaf up like a cigar roll when they put their little larva in it. And then you have all these leaves that never open up, and they kind of made a mess down there. They made a big mess. They took leaves this big and just destroyed them. So producers, consumers, decomposers. So you guys, there is going to be some controversy over what gets categorized as a decomposer versus a consumer. So when you have, we'll get to it in a minute, but when you have things like scavengers, sometimes people will lump them as decomposers and sometimes as consumers. Are you with me over there, girl? Like, shh, I can shield the phone. All righty, so here we go.
Just texting me and saying she's actually coming.
Oh, okay, all right, excellent. Tell her we'll see her soon. And your mom's birthday, right?
Yes.
Awesome, that's so cool. So what are our producers? All right, producers make what? Make their own, yes, Drew? Make their own food. Okay, good. So producers make their own food. Somebody give me an example of a producer. Anybody have one? Yeah, what you got?
Flower.
A flower, that's a good one. Yeah. Anything that's a plant. What else, Drew?
Is that those plants in general?
Plants in general. Yeah. Okay, cool. So yes, when you have things like producers, generally sunlight is going to be their source of energy, but this isn't always going to be true. There are going to be some producers that use different types of minerals and elements from the atmosphere or from whatever substrate they're growing on, and they will use that to produce energy. And there are some things that, I mean, you'll never see them in your life, because unless you become like a marine biologist and you work on deep sea vents, when you get way down into the deepest parts of the ocean, you can find some of these guys. And others you just don't notice, but they're around.
Chemical soup.
Chemical soup, yeah, so there you go. So your sunlight is your source of energy. So in that forest right there, everything that lives in that forest, except for the things that we're going to call chemotrophs that get their energy from chemicals as opposed to light, they're all getting their energy from the sun, right? Everything, you get your energy from the sun, essentially, if you take a few steps backwards. Because say you had a big bowl of strawberries for breakfast. Where did the strawberries get the energy from?
The sun.
From the sun, right? So you're consuming the sun's energy, but it's coming through sources on the way to you. Now, say you ate, say you had a steak for dinner.
I ate aliens for breakfast.
Yeah. Where do you get the energy from the steak? Where's the steak come from?
The sun.
Eventually, right?
The cow, but eventually the cow eats the grass.
Right. That's exactly right. So, yep, the cow ate the grass and then you ate the cow. And then there are some instances where you have like, say somebody eats in some places, like I think in Russia, they might actually eat like bear steak and things like that, which is really kind of random.
It's not China.
Yeah. But then you have an example of an animal that ate, well, you could say it even with a chicken, okay? Because chickens eat worms too, right? So now you're dealing with another level of consumer. So you've got a chicken that ate a worm, and the worm ate something in the ground, or chicken ate a bug and the bug ate a leaf, right? So you keep getting steps up higher and higher, but it all is going back to the sun.
It's like that pyramid.
Shh, don't talk about dog festivals. That's terrible. We don't talk about eating dogs. That's awful. That's not, that's not,
made me cry.
yeah, that's not typical. That's only like in really rural villages. That you've been to China. So you were saying, Darcy was saying there's a pyramid, and there is. Yep. So we're going to do the pyramid in a second. So we have our consumers, right? What are you? Are you a producer or a consumer?
Consumer.
You're consumers, right? So you're living things that require other living things as a food source. Yep. And these are other organisms are your source of energy. So the same thing for these little frogs. These are freaking adorable frogs. Oh my goodness. I want to boop their little noses. And boop, they're just cute.
That probably would hurt.
Yeah. So you've got these adorable little froggies, and these adorable little froggies are going to get their energy from bugs or whatever. And usually they're eating insects, right? And that's where they're going to get their energy from. And then those insects got it from whatever they ate. So then you have your decomposers, and this is where it gets a little sticky. So your decomposers are living things, especially soil bacteria, fungi, or invertebrates that decompose organic material. Okay, now here's an invertebrate, sorry, that helps decompose. Yellow jackets. I think did we talk about it in the other class? I talked about it with one of you guys last week. But if you leave, like I had a little snake die in my front yard several years ago, a little tiny, like a little garden snake, little itty bitty thing, no bigger around than my finger. And over a course of days, I watched the yellow jackets destroy it because they eat it. So they're eating it, but it's already dead. So they're helping decompose it. And when you categorize consumers as decomposers, it usually has to do with the fact that what they're eating is already dead. What you got?
Vultures are also decomposers.
Vultures, that's another one. Okay, so carrion. So vultures, turkey buzzards, turkey vultures, whatever you want to call them. We have a lot of them around here. They are strange looking creatures, and they will eat dead things. But without them, it would take a long time for the bacteria to take apart one of those deer. You ever seen one of the deer on the side of the road that's been, unfortunately smacked by a car?
Yesterday.
Yeah. Have you ever seen the vultures working on it?
Yeah.
Man.
I saw them pulling out its liver.
Yeah, it's really amazing. They work hard.
When we went on vacation to Kansas,
Yeah.
we found a squirrel lying dead on the ground.
Mm-hmm.
So when I came back a couple of hours later, a bee was pulling its eyeball out.
My dad is kind of an eccentric guy, and forgive me, but he likes to tell the story about how he saw a nature documentary once, and they talked about how vultures and buzzards go for the softest body parts first. So they take out eyeballs, and he said anuses, buttholes. That's what he heard in this documentary. And he has told a million people that vultures will take out a dead animal's butthole. But it makes sense. They go for whatever is soft and accessible, and animals usually have some kind of a hide, or, they have hair on their exterior, makes it harder to get through. So they go for whatever spot's easiest. So yeah, they will take out eyeballs first. It's kind of, ugh. And if you ever find like Cole found a buck had died in the woods by our church. And I said, well, if you leave it another week or two, it'll be clean. When you go back, you can get the skull or whatever you want. It'll be totally clean, or darn close to clean, because the decomposers in our ecosystem will take it apart, be it buzzards that pull off chunks, or if it's just bacteria doing their job. Now I have a bunch of skeleton samples that I'll bring out sometime this year. I've got I think 3 or 4 deer, some possum, I think a bird. I have all kinds of like partial skeleton pieces, and they came to me relatively clean. Some of them I found, some of them, like Drew found the possum, I think, at church. And my cousin found what she thought was a dead deer in the woods. And once I got a hold of it and started really looking at the bones, I, texted her back, and she shipped it to me from Virginia. And I was like, no, this is 2 deer because I have 2 sets of hips here. So,
Have you ever just seen like a dead squirrel or possum on the road?
mhm.
And if you've seen a dead possum, you're just like, I wonder like which direction they came from and
Yeah.
what time they came and got hit.
Yeah.
Are
We
gonna be disinfecting the phones?
will dissect a frog. Yep. We have
I would
frogs on our
definitely
list.
do that.
I already have them upstairs. And we do have an option. We have a non close-up option. If you would rather do it virtually, we have that for people who are going to be squeamish, but true. But what I was going to say, so I get these bones from my cousin. I realize I've got 2 deer, like a mature doe and a young doe, based on their size and their teeth, the wear on their teeth, you could tell. And so I soaked them in bleach for a while. And if you have new bones and they're not brittle from being out in the sun, you can actually boil them in water or bleach water, and that'll clean them off really well. So the ones I have are like pristine, white, beautifully clean. They're very cool. Yep. There you go.
Our family
Thanks, Drew.
friends, he likes to hunt from his back porch, and he shot a deer once with a crossbow, and he went over and he literally cleaned the entire deer clean. So now he has like a whole deer skeleton.
That's cool. I love it. So here is a mushroom that you probably recognize, right? You've probably seen similar mushrooms out in the woods, in your yard. Now, something to know when you see a mushroom, and when we get to our fungi unit later this year, we'll talk about it. But that right there is only the smallest part of the mushroom. That's called the fruiting body, and it's the reproductive part. So when that pops out, that's the mushroom trying to make more mushrooms. And if you have a nice, clean kind of open area, like a front yard or something like that, where they start to grow, if you watch, they tend to grow. Anybody ever notice what shape they grow in?
They sort of grow in a circle.
They do. Do you know what it's called?
No.
It's called fairy circle. People call it a fairy circle because the idea is, that at night while you're sleeping, all the fairies hang out on the toadstools and have a meeting because they're in a circle, which is totally just legend, but it's a great visual, right? They're all sitting there having a little meeting.
These really big mushrooms just sprouted up in my yard
Uh-huh.
overnight, and we're just like, how?
Yep, they grow very fast, insanely fast. Well, see, here's the thing. The reason they look like a circle, most of the mushroom is underground, and it's called mycelium. And it's like little hair-like, root-like things, and they go everywhere. And here's the interesting thing. We're learning more and more about mycelium and how they function because they're everywhere, but they actually sort of make a telecommunications network for all of the plant life in a forest. So they connect trees to trees, and they help pass information, strangely enough, from one tree to another tree through fungi mycelium, which we're just learning. If you have Netflix, you may want to write this down. If you have Netflix, there is a documentary called Fantastic Fungi that's on right now. And there's a dude in it who's kind of a hippie, and he didn't get like a formal education in fungi or whatever, but he started mushrooming as a young man, and now it's like his thing. He hunts them, he grows them, he whatever. There's a little bit of language in it, and then there's definitely discussion of people who take the hallucinogenic mushrooms and which have a trippy effect, like they use them like you would use an illicit drug, but they use them because they're quote unquote natural drug. So there's definitely conversation of that in it. So if that's not cool with you, don't watch it. But the part about the conversation and the data is amazing.
I would saw TED talk about that. Like
TED Talks are amazing. Yes. Yeah, there is a TED Talk. I've seen that too. So here are types of producers, our autotrophs. All right. Our autotrophs are what we call producers. That's the big word for producers. That's the formal word. Troph has to do with energy. So when you see this word here, troph, it's going to be energy. Like you'll see trophic levels in a trophic pyramid because we're talking about energy levels. What's photo mean?
Photosynthesis.
Photos in those words. Okay, photos in the word photosynthesis. It's also in photography. And it's in, what else? Can you think of it?
Oh, study.
No, not study. That's ology. Photo means light. So what does auto mean, do you think? Automobile, autobiography, autograph.
Technology.
What's an autograph?
Picture.
You get someone's autograph, what do?
Right.
They sign their name. If graph means write, what would auto mean?
Quick write down.
You, right. Auto means self or you or on your own. So an automobile moves itself, right? It's a machine that moves itself, right? Autobiography is a life of you write about your life as opposed to a biography, which someone else writes about your life. So what would a photo autotroph, when you put the three chunks together? Photo's light, auto is self, and troph is energy. So what would that be? Photo autotroph.
Getting energy by yourself from light.
That's it. Yeah, you guys got it. So photoautotroph is an organism that can produce its own food using light. They also use water, carbon dioxide, other chemicals. So that's a photoautotroph. And they use photosynthesis. There we go. So energy is going to enter the system as sunlight. Most producers use photosynthesis, and some examples are going to be plants, algae, and some types of bacteria. Now, we're going to be using an algae today in lab. And here's something really cool about certain types of bacteria. So cyanobacteria, which is, we call it sometimes blue-green algae. All right, and it's also sometimes lumped in with what we call phytoplankton. And those are all the little tiny microscopic organisms in the ocean that larger animals feed on. So where does the carbon dioxide in your environment come from that you breathe in? What breathes it out? Trees. Plants. Okay, so some people a couple years ago, yeah, what were you going to say, Louis? Water. Okay, we're getting there. Yep. So a couple years ago, there was a big deal where the Amazon rainforest was on fire, like big chunks of it. And people were horrified, and with good reason, because the biodiversity in the rainforest is incredible. Go over there if you're going to blow your nose and wash your hands. Thank you. And so the biodiversity is there incredible. We don't want to lose that biodiversity. It's amazing. So we shouldn't want it to burn. But people were posting memes all over social media going, oh my goodness, the rainforests are the lungs of the planet. We can't lose them. If we lose them, we won't have any oxygen because they're going to inhale all the carbon dioxide. They won't exhale any oxygen, right?
I heard that water is actually 70% of the oxygen.
It comes from organisms in the water, right? So most of the oxygen that most of the oxygen that you're breathing in is coming from the phytoplankton in the ocean, not the Amazon. They're contributing, and all the trees are contributing, and they're important. But when you breathe in oxygen, most of it's coming from the phytoplankton in the oceans. Now, the Amazon has a purpose because the way it flows, it actually allows for it's like a current in the sky that moves some of that oxygen from one side to another. And I can find, there's a documentary for that too that was really good that I'll have to show you about. So we have our photoautotrophs. And we put those three chunks together. We know that it means organisms that get energy, produce energy from light, right? Now, does all energy in a system come from sunlight? No, we don't. So not all are photosynthetic. So then we have chemosynthesis. So photosynthesis means you're making it from light. Synthesize means to put together, to make or to form, right? Making from light. So what would chemosynthesis mean, Drew?
From chemicals.
Right, making it from chemicals. So there are some organisms that are going to make energy from chemicals, and then they're going to release that that chemically produced energy into your system, whatever that is. So a photoautotroph is an organism that makes its own energy from light. Then what's a chemoautotroph? Photo was light, so what's a chemoautotroph? Yeah, right. Those are organisms that make their energy from chemicals. Very good. Their own energy. Now here's a word. Most chemoautotrophs are extremophiles. There's a fun word. All right, I'll tell you this. Phile, if you see phile or philic, like Philadelphia, you ever heard of, Philadelphia is the city of brotherly love. Philos it's a Greek word. It's a Greek root. It means love or like a lot, basically. It's love as in like want to adhere to and like, not romantic love. It's a different kind of love. So if something is philic, like you'll hear something as hydrophilic, it means it likes water. It will bond with water. It will mix with water. So what would an extremophile be, do you think?
Does peta mean child?
It can mean child, or don't go there. It can mean child, it can mean foot, peta is one of those ones, depends on how it's used. Peda versus pedi.
So peta can mean child?
Yes, it can, like pediatrics. pediatrics. So extremophile would be something that loves extreme conditions. So these are bacteria or archaea. Archaea would be archaebacteria, which we'll talk about later, that live in hostile environments like deep sea vents and are primary producers in those ecosystems. So they convert inorganic carbon, like carbon that's a mineral, into carbon dioxide. And that's an example of one of these bacteria. That's a chemoautotroph extremophile. That's a great word, extremophile. If you can keep some of these roots in your head, like phylophilos, synthesize, photo, auto, all these things, troph, they will help you. You'll be able to figure out what things mean. So whether a photoautotroph or chemoautotroph, food energy in an ecosystem comes from the producers always. So here are decomposers. So we have, here's one, heterotroph. If autotroph produces its own energy, what's a heterotroph, do you think?
They just feed off other people.
Other. Okay, so hetero would mean other or different. All right, so when we get talking about genetics, we're going to see the word hetero fairly often. And you may have heard heterosexual, right? You heard heterosexual, that means different. Like that's what you're attracted to, a different. So that's hetero. And so a heterotroph is an organism that cannot produce its own food, instead taking nutrition from other sources of organic carbon, mainly plant or animal matter. You are a heterotroph, right? You cannot produce your own energy. Now there are different kinds of heterotrophs. Remember, troph means energy. So an organotroph is an organism that obtains energy from organic compounds. So remember, organic compounds are those that contain what 3 elements? What 3 elements? Do you remember? Carbon, hydrogen, and oxygen, right? In all kinds of orders. So sugars, lipids, protein, we talked about them last week, organic compounds. That's pretty much everything that grows in nature. Not minerals, not rocks, but everything that's growing and living is organic. So are you an organotroph? Yes, you are an organotroph, not kind of, totally. You're an organotroph. You're also a heterotroph. You're not an autotroph or a chemoautotroph. Now there's also your decomposers, which are a type of organotroph. So these are things, you have primary, secondary, and tertiary decomposers. So these eat dead material, animal material. You got bacteria and fungi primarily. But then sometimes you get lumping in these guys. So this is what we were talking about before. Truly consumers, but sometimes lumped in with decomposers, are what we call detrivores and scavengers. Now, you know what a scavenger is, right? What's an example of a scavenger? You gave us one earlier, Lewis. What was it?
Yeah, a vulture.
A vulture. Okay, vultures, buzzards. These are scavengers, right? Animals.
Lions.
Lions can sometimes be, but they hunt too.
Oh,
Right?
hyenas.
Hyenas are a great example, right? They will hunt too, but they'll just as happily eat something else. The meat, true. Get serious. All right. So scavengers are decomposers that eat dead or dying organisms, typically dead animals, right? Detrivores are like scavengers, but they eat what you would consider like tiny lumps of dead matter. So where you would consider a vulture a scavenger, you would consider a worm a detrivore, or a yellow jacket a detrivore, because they don't take huge chunks away. It's just little lumps. Does that make sense?
Yes.
Yeah. So then, that last bit. So decomposers return raw materials to the environment. If it's a bacteria, they break it down and those compounds go right back into the environment. If it's a vulture, they're going to return it to the environment the same way you do, which is through waste. Same thing for detrivores. They produce waste, and that's how raw materials get returned to the environment.
I ran over a worm on my scooter before, and I went inside because it was getting a bit too hot, not knowing that I did it. When I came back outside about 30 minutes later, it was like ants and bees
Ants.
everywhere.
Ants are another great example. Yep. So heterotrophs. So we said this, you're a heterotroph, right? An organism cannot produce its own food instead of taking nutrition from another source. So where's your organotrophs again? All right, so here's where we are. I think you had a similar chart in your notes.
Yeah.
So if you may want to check it if you're not sure that you had it right. But your herbivores are going to eat only plant material. Your carnivores are going to eat only animals. Your omnivores are going to eat both. And then really your scavengers are going to eat dead or dying material. And what now? I didn't hear.
You're going to basically eat anything.
Anything. Yeah, anything that's left that's dead. Now, some of them will only eat dead animals and they won't eat like dead vegetation. They don't care about that. But
Where do I put
when we're done, you can stick him up there in the folder.
The
Sure.
last one eat a lot. Isn't really, but I mean, aren't all scavengers either carnivores, omnivores, or herbivores?
Generally, yeah, they fall into one of those groups. So scavengers are a little different because of the way they lump. So here's something to think about. Think about, anybody ever seen a horse's mouth? You ever been up close to a horse, seen its teeth?
Yeah.
What does teeth look like?
Like flat,
Square.
like ours.
Flat and yeah. So why?
Like our
I'm gonna grab Ozzy. Yeah, like your molars. Very good. So why are they that shape, do you think?
Are you gonna show Ozzy's teeth?
Why do you think that a horse's teeth is flat like that? What's a horse eat? What's a horse eat?
Carrots.
Carrots. What else?
Greens.
Grains.
Yeah, grass, grain, hay. Right. Do horses hunt animals?
No.
No, they don't. So those flat teeth are used for grinding. Do you have teeth like that in your mouth that are relatively flat?
Yeah.
Yeah, where are they?
Your back.
In the back. So those are your molars, right? All right. What kind of teeth does he have? Do they look like a horse's teeth?
No.
No. What are those teeth for?
Those teeth are for
Hunting, correct. So what kind of a consumer is a
Yeah, she
horse?
broke a horse's toy.
He did.
That's how sharp his
What
teeth
kind of a consumer is a horse? Where would he fall in up here?
are. Herbivore.
An herbivore. How about a dog?
Omnivore. Most kind of carnivore, but mostly. not.
Eh,
He's a carnivore because he eats meat in his
He's
food.
carnivore because he is meant to eat meat.
But he did.
But if I drop a piece of fruit on this floor, this dog is gonna eat it. He'll
Yeah,
eat
shut
bread. So that is what you call an opportunistic omnivore, meaning if he has an opportunity, he'll eat it, but it's not what he's built to hunt, digest, and consume. If he lived out in the forest and saw a mushroom that smelled good, he might munch that down, but he is meant to hunt. That's what these are for. Now, do you have teeth that look anything like these in the front?
No.
Yeah, you do. You've got these 4 and then these canines, right? So what are they for?
Those are for fighting.
Yeah, tearing, biting into. That's what he has. Even his molars, pardon my reach, Ozzy. Even his molars are not flat.
He's like, what the heck, mom?
Right. Even his molars are not flat like your molars. His molars are all pointy because he's meant to be tearing apart other animals. That's what dogs are meant to do.
You're fierce at it.
Yeah, he's fierce. Look, fierce. So
Like a
where would you, so we've decided the horse is going to be an herbivore, dog's going to be a carnivore, but an opportunistic omnivore, right? And how about people? Where are we going to be?
omnivore.
We are omnivores, right? And there will be people that will argue that we're not meant to eat meat. Oh, it's just terrible. We're not meant to eat meat. I'm like, look at your teeth. Look at your teeth. That's all you got to do is look at your teeth.
Some people are herbivores.
Yeah, some people choose to be, which is absolutely fine if you choose to be. But there are people who will argue that that's what we're meant to be. And I'm like, I think if you look in your mouth, you might make a different decision about that. So let's see, what else do we have? We have food chains and food webs, right? So your food chain is step by step, and it talks about trophic levels. So you start down here, you got your first level, you got a plant, and your second level, you got this little grasshopper. Your third level, you got that poor little, what is that, a field mouse or something, ate that grasshopper. Ugh. So now it's got the energy from the grasshopper and the plant. And then you got a snake that ate the little mouse. Poor mouse. Look at the, can you see it? Little mouse's little legs are in the snake's. And then lastly, you have this hawk who ate the snake. So your carnivores are always going to be at the top, and your herbivores are going to be closer to the bottom, and your omnivores can be anywhere in the middle or at the top. And then you're always going to have your producers at the very bottom, right? Now you got a food web. Food webs are going to be different. And food webs are going to show the relationship between things. So it doesn't just say the deer eats the grass. It says the deer eats the grass and the tree. And the chipmunk is going to eat the fruit that comes off the tree. And the bird is going to eat the spider in the tree, right? Everything is interrelated here. And this is more accurate when it shows how an ecosystem works. The point of a food chain is to show the path of energy. And the point of a food web is to show all the possible paths. So as an organism, you can play more than one role. So in this case, you've got this bird, right? And this bird's job is to eat this, whatever that is, a spider, and to eat this grasshopper, but something right there ate the bird. And I've been trying to figure out what that is. I think it may be a snake or I don't know what it is. Anybody want to guess? It looked like a caterpillar. I don't know what it is. Something eats the bird.
Maybe an arrow.
Maybe, I don't know what it is.
It's an owl.
Could be an owl. Yeah, the owl does eat the bird for sure. He could. So here's a close up of what you got. You got your sun putting energy in the grass. The grass is putting energy in the mouse, and the kestrel, which is a type of carnivorous bird, right? Is going to be, I think it's a type of raptor technically, is going to be eating that poor little mouse. Oh, sorry, mouse. Run, little mouse. So what we do is we call these primary consumers, secondary and tertiary, as we start talking about different levels of consumers. So he's going to be a primary consumer. He's going to be a secondary or second level consumer. And you can keep going up different levels, right? But really all you need to know is that it just keeps advancing basically.
We're at the top.
We're at the top. Yeah, pretty much. And now if we were in the African savannah, I don't know that we'd be at the top. We might be.
Do you have a gun?
Well, it depends. That's right. Have you leveled the playing field with that lion who's really hungry? So here you have your trophic levels and your energy flow. So your trophic levels. Now, this is what's important to understand most of all. It's really kind of easy to get the concept of, oh, your energy moves, energy moves up levels. But here's the thing. This guy at the top, it takes all this grass to supply him with the energy he needs. Because all this grass goes to these 4 rabbits. And these 4 rabbits require this much grass to live. Now, these 2 snakes require this many rabbits to live. And this bird requires these 2 snakes. But what happens at every level is you lose energy, and you lose the energy through life processes of the different organisms involved. Okay, so if you are a rabbit, and you ever pet a rabbit? Rabbits are warm, right? They're warm because their body is metabolizing. Their body is undergoing aerobic respiration, which we'll talk about later. And while their body is metabolizing, they are losing energy through heat, right? Yeah, you lose energy through heat. Okay, everybody loses energy through heat. And so all of these organisms are losing energy through heat or through other processes. Every time you move, you're burning calories, right? Calorie is a measure of heat. So if you think about it, when you run, you burn more calories than when you sleep, but you're still burning calories because as long as your body is physically warm, that's because you are producing heat, and you're producing heat by burning those calories.
You burn a lot of calories when you're sleeping, actually.
You actually do, because your body does all of its repairing and stuff while you're sleeping, which takes a lot of energy. So you get your energy flow going up trophic levels, and this just gives specific examples of where your heat loss takes place and where your calories are. So right here, it says your rabbit. If your rabbit is 1,000 kilocalories, it takes him 1,000 kilocalories here. That's the energy he's getting from the grass. Then by the time he loses energy, the snake's only going to get 100 kilocalories. And then this guy at the top is only going to get 10 from that original chunk of grass. So the organisms at the top, there are fewer of them because the energy up there is so limited. Think about it. Is there more grass in the world or more tigers? Way more grass, right? And is there more, are there more worms or robins? More worms, yeah, because the energy as you move up the food chain food web, food pyramid is going to get less and less and less. So the energy at the tip top is very limited, and there are less of those organisms than there are of others.
There's more worms than there is grass. There's more worms than anything.
Well, those are different kind of worms.
But there's still worms.
I should have specified and said
Actually, I'm not
earthworms.
sure about that.
What?
I don't think there are less. Are there less worms than there are grains of sand in the world?
It depends on the kind of worm you're talking about. I should have specified and said
Every single
earthworm.
worm of every different.
Oh, well, then, yeah, that would be crazy. But when we get talking about,
Everything has worms on it.
we get talking about nematodes, which are roundworms that are sometimes microscopic and you can't see them. I read a great little blurb once that I've saved because it was so cool, but it talked about how they're on every surface everywhere all the time. And if you were to somehow make everything disappear in the world except nematodes, it would be like there was a shell of everything that formerly existed, and it would just be made of little nematodes, which you can't see with your eyes because they're so small. All right, so let's wrap up with our cycles of matter. So matter is anything that has mass and takes up space, right? That's a basic matter definition. Everybody should know that one. Matter is composed of atoms, right? And 2 or more atoms joined together acting as a unit are called a molecule. Now, this is important to know. And the other group, this is what they missed most on their test. If those 2 if those two atoms together are the same atom, like oxygen and oxygen, oxygen's never alone. He's always with his other oxygen friend. That's just the way they function in the world. That's a molecule. But if they're two different, it's more likely to be a compound. It can be a molecule if it has a molecular bond, it gets complicated. But if you keep in your mind that if they're different, it's usually a compound. And if they're the same element, then you got a molecule. So important cycles of matter include, here's a bunch of them. So we're going to look at them real close as we go through. I don't know where that question came from. I do not remember. I'll have to look in a minute. So water cycle. All right, you guys are probably very familiar with the water cycle. Is there anybody who hasn't really talked about the water cycle before or studied it? Probably really familiar with this one. You know, you've got evaporation, it goes up, makes clouds. We have what we have today, tons of precipitation, comes back down, gets into the water, goes to the ocean, evaporates, goes back up. You know this one, right? So water evaporates, clouds form, and then what happens?
Rain.
Yep, you get precipitation. So it doesn't have to be rain. It can be snow, sleet, or hail, right? And then you have precipitation that runs off or it becomes groundwater and then it goes back to evaporating. Now, did you guys see this one in your notes?
Yes.
So consumers take in oxygen for their life processes and release carbon dioxide as a waste product. Most organisms are going to use nitrogen that's been fixed by bacteria in the soil, which is a more complicated concept that we're not going to get into right now. But nitrogen fixation is like a whole big thing in ecology. So you have oxygen and oxygen going into this horse and carbon dioxide coming out, and it's going back into the tree and the horse in the tree and the horse in the tree. You guys are probably familiar with that. All right, so this is going to be your homework. This is your reminder that you have homework this week. If you have a test, you're not going to have homework because you're going to study. If you don't have a test, you are going to have homework. So your homework is going to be right here on Teacher Ease. You're going to log in and your assignment's right there.
Yeah.
Sometimes your assignment will be something like download and complete and upload like you did with the drawing, which I think almost everybody got. So that's good. Sometimes it'll just be, it'll say it's a quiz. It's not counted like a test. It's just the way the setup works. And you answer the questions, or sometimes it'll be a discussion. Tell me something, right? These are brief. Homework are quick and brief. They shouldn't take you very long, right? And that's the idea behind it. So did anybody have any questions about this last week's unit? I mean, last week's chapter, the study in this week or lesson? So good. All right, good. Because what we're going to do is we're going to keep building on ecology. And when we finish the whole concept of ecology, then we will have ourselves an ecology test on unit 1. So for your lab, to answer your question about your lab, Miss Lil, because I'm never quite sure if I don't, your lab is right here. And it should say, oh, it's going to be over in the other thing. Oh, look right here real quick. Oh, come on, computer. Look at that. It's going to fight. It's going to fight me. It's going to argue with me first thing in the morning. Next week, probably won't apply to you, but just so you know, I just want everybody to know, I am leaving Tuesday afternoon, very shortly after class. And I am going to Virginia to take care of some stuff with my dad, who has been very sick and has had 2 strokes since May and has been in rehabilitation and assisted living and is starting to have real problems. So I will be gone. I'm going to take my grading with me and I'm going to try to get it all done. But please understand if it's not immediate, like it was this last week, it's just because I probably don't have internet or I'm dealing with him. So here is your answer to your question, Lily. It should be written down here. I'm pretty sure you have to hang on to it till next week because, so yeah, right here, you're going to keep your lab in your binder and we're going to hang on to it till next week because this lab takes a full week for you to get the data you need. And Drew and Cole, I'm going to need you guys to probably help a little bit with pictures.
Something like it has to like form.
It has to grow. We're going to grow algae. Yep. So I'm going to go ahead and stop this. And if you need a stapler for your lab, which I recommend, there's one up there where the folders are. You can go ahead and turn in any RICO that you have.